Hi, my name is Hannah Clark-Havron, and my research topic that I was looking into for E6 is using EvoMass for optimization-based design exploration. First off, what is optimization-based design? According to the creators of the EvoMass plugin, optimization-based design is aimed to leverage optimization as a means of information extraction for achieving a performance-aware or performance-informed design synthesis process, rather than purely looking for a design solution. So optimization-based design helps reveal architectural information relating to building performance. It also helps explore multiple design alternatives, and it uses results of optimal performance studies to inform and encourage the design process. Okay, so next, what is the EvoMass plugin? So EvoMass is a Grasshopper plugin that can be used for building mass design generation to explore optimal design. So it can be used for rapid virtual prototyping of building massings. It uses subtractive or additive form generation principles. It also includes an optimization or SSIEA algorithm that can output several high-performing design solutions, and it creates variants with high design variability and differentiation, which is why this plugin specifically stands out against others that do things similar. They've stated that you either get variability or differentiation, you don't usually get both. And so the version that I will be using is 0.3.0, and I have included the link here at the bottom to the Food for Rhino app that you can download it at. Okay, so next is the demonstration video that I did on how to actually use the EvoMass plugin. So that is included here in the presentation, but at the bottom there is also a link to YouTube where you are able to watch that demonstration video separately if you're interested in doing that. And here is the demonstration.
Okay, so you want to start by going to Food for Rhino and looking up the EvoMass plugin. So this is the one right here. And when you get to it, you're going to want to go down and download the newest version. It is the v.0.3.0 with examples. So then you're going to go into Rhino and open that up. And then from there, you're going to want to go to Grasshopper. So then Grasshopper will take a second to load, but once you get that open, you're going to want to go to the EvoMass plugin. And then from there, there's two that you're going to want to use. I'm going to use the subtractive, but there's a subtractive and additive generative component. And then you're going to click on setup, and that's going to bring up this parameter box. So then you're going to go through, there's a lot of different parameters that you can adjust. You can adjust floor heights. There are some limits. They're not really specified, so you might just have to play around with a couple things. But you can change all the parameters. You can change the floor minimum number and like the maximum number as well. You can change the column grid number, and then in X and Y. And there's just kind of a lot of different things. You can change the vertical or horizontal subtractor amounts, the numbers, the sizes for both. So you can just play around with those. And then you can come down here and you can actually choose different exterior facade types. I'm just going to stick with the same one. You can do the same for interior. It specifies whether it'll be fast or slow to use, so I'm just going to stick with these because they're the fast ones. And then down here is where you're doing the rapid prototyping. So I am going to type in some numbers, but you actually have to set the parameter first, and it'll come up with 1. And then you have to go back, and so you can see like 1 massing here. And then you have to go back and click on sampling in order to do the rapid prototyping. So I have 5 rows, 5 columns, and then there's the sampling. So if you zoom out, you can see all the subtractive massings. And those are all according to the parameters I set, and just different versions of them. So let's go over and we can kind of see more what we have here. So there's just 5 rows, 5 columns of different massings that all work with what I set up there. So now I'm going to come back into Grasshopper here. It does kind of freeze up. We can see like you just have to go back in. But yeah, so there's the subtractive. Then you can go into advanced here and you can actually set a fixed void with the subtractive. So this would be like if you want like a courtyard or something cut out, and you can pick the starting point in X and Y and then the void size in X and Y. So this is if you want like a specific courtyard or void or something in your building, you can pick one that would be fixed. So if you were to do a sampling of them all, it would be fixed as well. But you can kind of see with the green there, like the void that I cut out there that I specified, and just kind of see how that works. So you can just really play around with it. Going back to basic, you can change those numbers if you want. If you do put a 0 for the horizontal subtractor number, it will only give you courtyards, so it won't cut out of the edges. So yeah, you would choose a number for the vertical subtractor number, and then the horizontal subtractor number would be 0. And that would only give you courtyards instead of cutting out of the facades. But yeah, that's about it with the subtractive. And then we'll go back in to Grasshopper here. Let's open it back up. Oh, well, actually, I am going to move these off to the side first. Just turn on Gumball, and I'm just going to move them all over. And then we can test out the additive component. So we will go back into Grasshopper here and pull down the additive component. And it's really similar to the other one. You press setup, go into the parameters. You can choose how many additive masses you want. Again, you can choose floor height, floor number, min and max. And then the difference here is the actual size constraint, but I'm going to do it without that first. So again, like exterior and interior facade, set the parameters, and then rows and columns, set those up for the rapid prototyping and click sampling. And this is just going to take a second. So there is the additive sampling, and I do still have the subtractive one up in Grasshopper, which is why you see that green box. But you can see all of the different additive prototypes kind of beyond it there. So again, I did 5 rows, 5 columns, and yeah, these have like a little bit of a different footprint, but the subtractive is taken like out of a rectangular like box shape, and these are kind of added together so you can see how they kind of differ a little bit in terms of like the footprint. I'll just zoom in a little bit here so you can see there's not really a lot of courtyards. Those were created from the subtractive, so it's just like a different form here. And then if you go back into Grasshopper, we want to go back into the additive. You can actually, this is the actual size constraint. So this is where you can choose like constraints. So you can choose a minimum vertical and a maximum vertical, and then a minimum and maximum horizontal. And then that will make sure that all of the massings that you create are within those constraints. So there was a limit I didn't match. So I am going to have to go back up and change something. So, okay. So if I unclick the set target gross area, it will work. It said like my parameters wouldn't work with the target gross area. So that's one way you can fix that. And then you can see I just created a couple more. So I will zoom in a little bit. And these are a little bit cooler. These are just a little bit different. They're not as boxy. Well, I mean, they're very orthogonal still, but the other ones have more of a rectangular footprint overall, and these are just kind of more varied, which is cool. So you can kind of see how those 4 differ from the rest of the ones that we did here. I'll try and zoom in here on these so they're a little bit different here. But yeah. So that is like really the additive component. So they're really not very hard to use, just setting those parameters. And then like you're able to rapid prototype all of these different massings super quickly, and they all meet the parameters that you set. So this is really nice if you're trying to like quickly come up with a bunch of different iterations. And yeah, it just really does it for you. It's very simple in Grasshopper. You can see here, like, I mean, they look pretty flat because there's so many, but if you come in from the side there, you can see how they vary in height. And then going back to Grasshopper again, now we are going to move on here. If we go back to the subtractor, this is the one I'm going to use for the optimization in the example. So I'm just going to kind of show you what we can do here. I'm going to simplify it a little bit. And then here's one of the options is shuffle massing. So this takes your parameters and it just shuffles it to show you different iterations with your parameters. I have the additive one still on there so you can see that. But yeah. And then if you go back in, shuffle the massing again, and then you can do shuffle parameters. So it'll highlight the parameter that it changes, and it'll just shuffle your numbers around. So if you're not necessarily looking for like a specific parameter, that is one you can play around with and get some different options. So here, let's see, I am going to get rid of this. Oops. I am going to get rid of the additive massing, and we're just going to work with the subtractive for this next part. So I'm going to go and shuffle the massing a couple more times so I find something that I like, and I'm going to get rid of the fixed void that we did earlier. And then go back, shuffle some parameters, set, and let's go with that one. So from here, I'm going to use some of the examples, or one of the examples that is included with the plugin. So if you go in here, these are the example files, and I am going to choose the annual daylight. And for this one, you do need to install Ladybug, and that is version 1.2.0. So it's going to take a second, and then it loaded in the Ladybug script. So I'll just zoom in. This is what it kind of created. And yeah, so here is the massing that we're going to be working with for the next couple minutes here. And then here is the script. So if we open this up and kind of zoom out, you can see that the subtractive massing, the EvoMass thing, was over on the side, and just kind of zoomed in here. So this is the other component that you can work with. It is the optimization component. So if we go back out and look at this, we see like a different form. And you go back in, you can adjust these parameters if you want. Yeah, so this is the optimization thing. So you'll click start, and according to the script, it'll come up with these different iterations that are most optimal. So you can see them like starting to form over there as the massing switches up, and then it just gives you some data points back in this chart. So it'll run through, it tells you in that last form how many iterations it'll create, and this one was 195, but I am not going to go through all of them because this is just for demonstration purposes. So you can kind of see there how you can work with optimization, and the Ladybug script is customizable and has all the instructions along with the other 4 examples. But yeah, so that is about it with EvoMass.
All right, so this next slide is the process slide, and this is basically just an overview of what was covered in that demonstration, but it just breaks it down into the basic process. So number 1, download and install EvoMass from Food for Rhino. 2, in Grasshopper, choose either the additive or subtractive generative component. 3, click setup on the component and enter the parameters for your massing. Some of these examples are span size and value in X and Y, number of floors, floor height, interior and exterior facade type, size and boundary constraints, number and size of additions, subtractions, etc. Step 4, set your sampling parameters. So this is where you would input number of rows and columns for your desired prototyping outcomes. And then step 5, you choose your operation. So you either shuffle massing to generate new massing options from your parameters. You shuffle the parameters, which shuffles your inputs, or you set parameters, and that is what's going to give you your outputs. So that's what's going to create your sampling set or your just individual massings. And after rapid prototyping, you can use the example scripts that are provided with the EvoMass download or other Grasshopper scripts to determine performance of massings relative to conditions of environment, site, etc. So what are the benefits and uses of this EvoMass plugin? Number 1, it easily creates multiple iterations of building masses according to parameters set by the user, providing options and enhancing information extraction to reveal optimal form. It doesn't require any parametric modeling or establishing workflow, which reduces time and speeds up the process of analyzing performance of different massings. It can be used for site analysis with respect to different environmental and performance factors. So, this could be sunlight hours, daylighting, solar irradiation, wind, passive solar performance, etc. The one that we worked with in the demo was a daylighting, but there are many other options, both with the examples and just other scripts out there. And finally, the iterations can be tested in combination with Ladybug to explore optimization. So this is the example scripts that were mentioned. There are a couple obvious limitations. The EvoMass plugin only creates basic orthogonal massings directly from your set parameters. So you'll still need to design your building. It doesn't do parametric modeling or anything. It just helps you find optimal shape. So you can use this for your performance-driven design. Later on, this is really an early iterative process. And then another thing that was mentioned actually by the creators is that it does not take urban environments into account, only immediate surroundings. So as you saw in the Ladybug script that we used, it did input a couple buildings on the side, and that's obviously customizable. You can adjust it to be like the immediate surroundings, but it doesn't take into account larger overall urban environments. And another thing is just in the Food for Rhino, it does say it's a newer script, it's a newer plugin, so there are some bugs. Nothing that I really noticed when I was working on it, but just some things like that you'll run into. But yeah, and then here are my references that I used for all of the information. And that is the end of my presentation on using EvoMass for optimization-based design exploration. Thank you.